Hello everybody. First of all, I think so this is the first lecture from 12th standard on XII for this year. So for all of you, welcome to 12th standard, and let's start with very interesting subject, physics. Now when we are going to think about physics, we are going to start with the first chapter. But before starting the first chapter, I want to introduce the first concept, that is motion. So from this motion, we are going to start with the topic circular motion. We are going to start with the chapter named circular motion. But this word, if you are going to check this word, then this word consists motion, word. So I want to discuss the complete part, that is circular motion. But before discussing some circular motion, let's concentrate on the word motion. So the first question is on your screen. What does motion means? This part we already discussed in 11th standard, that is what does motion mean? I want to ask you the same question. Please give me the answer, that is what is motion means? What does motion means? So when we are going to think about this, let's discuss its definition. Motion. What is motion means? Displacement of a particle from one point to another point is known as motion. Displacement of a particle from one point to another point with respect to other object is known as motion. Okay, so displacement of a particle with respect to other particle is known as motion. Is it right? This definition we discussed in 11th standard. Next, now what are the types of motion? This part also we discussed types of motion. So three types of motions are there: translational motion and linear motion, first type. Second type, circular motion or rotational motion, and third type is oscillatory motion or vibrational motion. So these three types are there. Which three types? Again I will repeat: translational motion or linear motion. Second one is circular motion and rotational motion, oscillatory motion. Now this translational motion part, this part we already discussed in 11th standard. Is it right? Now we are going to concentrate on the next part, that is circular motion. Now when we will think about circular motion, the second name mentioned over here, that is rotational motion. But take a note of it that rotational motion we are not going to discuss just now, because we are going to discuss it in third chapter. But the third next is oscillatory motion. So all these motions we are going to discuss in 12th standard. As I said, translational already you discussed in 11th standard. Is it right? Where you discussed this translational motion in 11th standard? Can you tell me the names of chapters where you discuss this linear motion or translational motion? Another any chapter? The next chapter of projectile motion, what was the name of that chapter? That is also from translational motion. The name of that chapter is force chapter. Is it right? Force concept. When we were discussing force concept, we concentrated again only on translational motion over there. But now, as I said, we are interested in circular motion in this chapter. Then we are going to discuss rotational motion in third chapter, 12th standard, and again oscillatory motion or vibrational motion we are going to discuss in fourth chapter. But first, initially, we are going to concentrate on circular motion. So obviously, when you will ask about circular motion, what is circular motion? Yes, it is in front of you. Motion of a particle around the circumference of circle is called circular motion. So you can observe over there in this animation that one ball is there, and that ball is revolving like this way. Is it right? So motion of particle along circumference. That ball is moving along circumference of circle. Is it right? So the motion of the ball is which motion? It is circular motion. So what is the definition of circular motion? Motion of particle along the circumference of circle is called circular motion. There is one more example of circular motion which is in front of you, that is electrons revolving around nucleus. Electrons are revolving around nucleus in which orbit? Circular orbit again. Maybe that circle is horizontal, inclined like this way or like this way, or vertical as you are observing over here. But the motion of an electron is which type of motion? Circular motion. Okay, getting it? So any other example? Motion of electron along nucleus is circular motion. Yes, there is one more example. That is, moon is revolving around earth. Moon is revolving around earth is again a circular motion. Moon is revolving around earth is again a circular motion. Earth is revolving around sun. Is it circular motion? I think so. Earth is revolving around sun is elliptical motion, not circular motion. But definitely moon revolving around earth is which type of motion? Circular motion. So first example we discuss over here, that is ball revolving around circumference of circle like this way, circular motion. Second example we discuss electrons revolving around nucleus, and third one, that is moon revolving around earth is also circular motion. Now let's consider this diagram. In this diagram, the central point or center of the circle is O. Now we are observing top view of the previous first example, this example. Okay, that ball is revolving like this way, no? Initially that ball is at point A. After some time that ball will reach at point B by covering angle theta. Is it right? If that ball will reach at point C by covering angle delta theta. Like this way, the motion is circular motion. But now I want to ask you one simple question. Suppose there is a stone attached to a thread and I am whirling that thread like this way. Okay, I think so you are knowing the story of David and Goliath. What David did? David tied one stone to a sling, David's sling, and he started whirling or revolving that stone. If we are going to stop revolving, what will happen with the stone? So tangentially outward. So obviously it will follow that arrow which is shown over here, the tangent to the circle. So it will move tangentially outward. One more example we can discuss, that is you are traveling through vehicle and suppose your vehicle will pass through mud, then mud particles will stick to the wheel. Is it right? Wheel is rotating like this way. When wheel is rotating like this way, and those particles will over here at the bottom, in which directions particle will get thrown? Particle will get thrown in this direction when wheel is rotating like this way. Is it right? So they will get thrown tangent to the tire. Tire is circular. Is it right? So it will get thrown tangent to the circular tire. So similarly, it will travel tangent. So what the tangent will indicate you? The tangent will indicate velocity of the particle. What the tangent will indicate? That tangent will show us direction of velocity of particle. Getting it? What the tangent will indicate? Direction of. Take a note of it. It's very important part. So I am revolving in this diagram which is in front of you. I am revolving a particle, and I will stop on the dotted line after C, which is present after C. So I am rotating it like this way. I will stop over here. So that stone will fly in this direction, that is tangent. What that tangent will indicate? That tangent will indicate direction of velocity, linear velocity of the particle. Hope so you are getting it. If you are not getting any point from my description, you can ask it to me in the chat box. You are very free to ask me doubts. Okay. So next concept is in front of you, that is position vector or radius vector. What is position vector? See, I will read first definition. A vector drawn from center of circular path to the position of particle performing circular motion at an instant is called position vector or radius vector. Means what? See, over here the center point is O. Center point is O. A line drawn from O to A, O to B, O to C are the position vectors. Why? Check again definition. A vector drawn from center of circular path. Where is the center? We are knowing center of the circle. Is it right? So suppose the center is O. A vector drawn from center of circular path to the position of particle. Initially, suppose particle is at point A, then obviously OA is the radius vector. After some time particle will reach at point B, then OB be the radius vector or position vector. After some time it will reach at point C, so it will be position vector will be OC. Is it right? Like this way, what that position vector or radius vector will indicate? That radius vector will indicate position of the particle at that instant. Position of the particle at that instant. Okay, getting it? I will proceed further. Next concept, that is angular displacement. So the concept is very simple. What is angular displacement? Angular displacement theta of a particle in a given time is defined as, now definition, angle traced by a radius vector. So we discussed, no? OA is the radius vector. So this radius vector will move to OB. So OA to OB is angle traced by the radius vector. Is it right? So angle traced by its radius vector in that time at the origin of frame of reference means we are where the frame of reference, we are going to situate frame of reference at origin, means O will be our origin, then OA to OB. This motion is nothing but the OA to OB. This motion is nothing but the angle. So angle A O B or B O A is angular displacement theta. So angular displacement BOA is equal to theta. I will repeat the definition. Very simple definition. Angle traced by radius vector. Angle traced by radius vector is known as angular displacement. So BOA is not correct. BOC. BOC is the correct option. Yes, Ashish is also right. BOC or COB is the angular displacement. Getting it? Then after this we are going to discuss one very basic concept that we discussed in 11th standard mathematics. Are you remembering this formula? It is angle equal to arc upon radius. So same formula is in front of you. But Meenal asked one question, but the angle should be from the original frame of reference. Yes, Minal, you are right, but where is the frame of reference? It's not at OA, it is O only. Means what is frame of reference? Frame of reference means the point at which you are assuming that you are present. So if you are present at point O, then initially initially OA is the radius vector. It is going to cover BOC. Now for you, initial distance is this. So COB. So O is the frame of reference. OA is not the origin. OA is not the origin. What is the origin? O is the origin. Minal, getting it to you, or still you are having any problem? Yes, okay. So I will proceed. So as I am discussing with all of you, that is what is angle. In 11th standard mathematics we discussed the formula is angle equal to arc upon radius. Is it right? So angle theta equal to arc. Check it over here in this diagram. AB is the arc. Is it right? So arc BA, angle equal to arc BA upon angle equal to arc upon radius. Radius is smaller. So theta equal to S. So that BA is nothing but the S, no? So theta equal to S upon R, or S equal to R theta. Similarly, for smaller angle delta theta, next angle is delta theta, no? COB is delta theta, that is smaller angle. Let BC is delta S. Let BC be the delta S. So delta theta is equal to delta S upon R. Delta theta is equal to delta S upon R. Angle equal to arc upon radius. Can you tell me the SI unit of angle? SI unit of angle. Radian, correct. Very good. Everybody typing correctly. As it is already typed over here, that is, it is expressed in radian. So angle we are going to express in radian. Many students are going to answer over here degree, which is wrong. That's very good that nobody answered degree. Degree is not SI unit. Radian is the SI unit. So angle theta equal to S upon R. So S equal to R theta. But now for full circle, S is nothing but a circumference. Is it right? So it will become 2 pi R. So for full circle, 2 pi R, RR will get cancelled, theta equal to 2 pi. So all these things are well known for you. Next concept, that is angular velocity. Now in 11th standard, if you are remembering, we discussed in projectile motion displacement, and then we discussed linear displacement. Is it right? So can you tell me what was the definition of linear displacement? Okay. Then what is the definition of linear velocity which we discussed? Definition of linear velocity. Be quick. I am waiting for the answer. Definition of linear velocity. Velocity, linear velocity means velocity. What is the formula of velocity? Okay. Okay, Ronit type rate at which particle moves. Is it right? Or the definition which we discuss, that is rate at which linear displacement, or the basic formula displacement with respect to time. Correct. Prototype displacement per unit time. Over here angular velocity. Obviously angular velocity is angular displacement per unit time. Angular velocity means angular displacement per unit time. So the rate at which angular displacement takes place. Whenever you are going to hear this word rate at which, what is meaning of rate? Rate means divided by time. The rate at which angular displacement takes place. So rate and angular displacement upon time is known as angular velocity. Angular displacement upon time is known as angular velocity. So the formula is omega, that we are going to denote with symbol omega. Many students are going to write W over there. That is wrong. It should be omega. W we are going to use for work. Okay. So average angular velocity is vector omega is equal to vector delta theta. Delta theta means angular displacement divided by delta t. The instantaneous angular velocity. What is the instantaneous angular velocity means? If suppose I just started revolving the stone, and after 1 second means I just started, and immediately you will ask me, please tell me angular velocity, please tell me value of angular velocity. Then I just started, no? So just started means time is how much? Almost zero. Suppose I started whirling the stone, and as soon as I will start, within 0.1 second you will ask me. So 0.1 second means almost time is zero. So at that time, we are going to write the formula like this way, that is vector omega is equal to limit delta t tends to 0, vector delta theta by delta t. So that limit delta t tends to 0 will indicate us time is very small, that is almost 0, that is equal to d theta by dt. What is unit of angle? Unit of angle is radian. What is unit of time? It is second. So it is measured in radian per second. When we discuss linear displacement, after discussing linear displacement, we discuss linear velocity. After discussing linear velocity, we discuss linear acceleration. Is it right? So similarly, after discussing angular displacement, we discuss angular velocity. The next concept we are going to discuss, that is angular acceleration. Definition is same again, like linear acceleration. Can you tell me the definition of linear acceleration? Or formula of linear acceleration? Similarly, now change in velocity per unit time is linear acceleration. Angular acceleration, change in angular velocity with respect to time. So here is a definition: angular acceleration, the rate of change of angular velocity or change in angular velocity per unit time is known as angular acceleration. Alpha equal to omega 2 minus omega 1 upon t. Omega 2 minus omega 1 upon t. So vector alpha is equal to limit. So omega 2 minus omega 1. Omega means difference. Omega 2 minus omega 1, there is difference. No? Difference we are going to indicate with symbol delta. So delta omega by delta t. Alpha equal to limit delta omega by delta t, where delta t tends to 0. That is equal to d omega by dt. And it is measured in radian per second square. We are going to measure it in radian per second square. Okay. So wait for a while. Now we are going to discuss one more concept, that is UCM. What is UCM? UCM means uniform circular motion. The motion of body along the circumference of a circle. Motion of a body along circumference of a circle. Till this point everything is same, but next part is important. With uniform linear speed or uniform angular velocity is known as UCM. Uniform circular motion. What is uniform circular motion means? Motion of a body along circumference of a circle. Motion of body along circumference of circle with uniform. Uniform means constant. Linear speed. See, deliberately we use one word, linear speed. Are we use linear velocity word over here? No, not. You may ask me question, sir, why then we are not using linear velocity? See, velocity will change point to point. How velocity will change point to point? Direction. Just we discussed, no? Velocity is always tangent to the circle. Is it right? So when velocity is always tangent to the circle, you can check. At point A, suppose is A point. Direction of velocity is this. At point B, direction of velocity is this. At point C, direction of velocity is this. Over here, direction of velocity is this. So at point A, direction of velocity is this. At point B, it is like this. Is it right? So is direction of linear velocity going to remain constant? Yes? No. Direction of linear velocity will not remain constant, and therefore we use particular word over here, that is uniform linear speed. Then, or uniform angular velocity, or angular velocity also will remain constant, uniform. Okay, so then we are going to call it as UCM. So simple definition is that what is UCM means? Motion of a body along circumference of a circle with uniform linear speed or uniform angular velocity. Done. Now two MCQs are there for you. Both MCQs on your screen. Please try to solve these both MCQs. Type your answers in chat box. Meenal type D, Neha type D. Okay. So is D is correct option? Yes, D is the correct option for first. Very good. Yes, D is the correct option. The reason behind it is, which options are present? Velocity, option A. In UCM, is velocity going to remain constant? No. If angular velocity were over there, then yes, that angular velocity is also the correct option. But angular velocity were not present. D is clearly mentioned linear velocity. Obviously, velocity and linear velocity, almost two things are same. See next concept, that is pressure. Obviously, there is no any kind of resemblance between pressure and UCM. So D option, magnitude of linear velocity. Yes, magnitude of linear velocity means speed. Magnitude of linear velocity means speed, and it will remain constant. Yes, so D is the correct option. Now before working on second MCQ, I will give you one hint, that over here omega is given to you. Determine the angular acceleration. So formula of angular acceleration is in front of you. Omega 2 minus omega 1 upon t. Is it right? So body which slows down, determine the angular acceleration for a rotating body which slows down from 500 rpm to rest. So omega 2 is 0. Omega 2 is 0 and omega 1 is 500 rpm. But this is not omega. Why not? This is frequency is given. 500 rpm is frequency is given. So you have to find out omega from the given frequency. How can you find out? I will give you a hint. I am not going to solve the MCQ. What is the formula for omega? Just we discuss. Theta upon t, d theta upon t. Is it right? When particle is going to complete, the whole circle, when particle is going to complete the whole circle, obviously angle covered is how much? Check. Angle covered is, it is mentioned, it is 360 degree. 360 degree means angle covered is 2 pi. So omega is 2 pi upon t. Is it right? But 1 upon t means frequency. Is it right? 1 upon t means frequency. So 2 pi n. 2 pi n. So do it and convert this RPM to RPS. See, as I said, the formula is 2 pi n. But n1 is given. How much it is? 500 RPM. No, you have to convert into RPS. How to convert RPM to RPS? To convert RPM to RPS, you have to divide with 60. To convert RPM to RPS, you have to divide with 60. So 500 divided by 60. 500 divided by 60 is 25 by 3. So 2 pi n1, 2 is 3.14 into 25 by 3 divided by 10. If you will solve it, its answer is minus 5.233 radian per second square. Now the main question is, okay, we discuss how to find out omega, that is formula 2 pi by t or theta by t or 2 pi n. With these three formulae, again I will repeat formulae: theta upon t, 2 pi by t or 2 pi n. Then alpha is omega 2 minus omega 1 divided by t. Omega 2 minus omega 1 divided by t. And now we are going to discuss next point, that is right hand rule. So with the help of right hand thumb rule, we also call it as right hand thumb rule, we can find out direction of omega and direction of alpha. Direction of omega and direction of alpha. So what is right hand thumb rule? Imagine the axis of rotation, underline the word imagine. Don't actually going to hold the axis of rotation. So axis of rotation is held in your right hand. Suppose this is the axis of rotation, okay, and you are going to hold it in your right hand with thumb outstretched and fingers are curled around it, okay. In this situation, if curled fingers indicate direction of rotation, then the thumb indicate direction of angular displacement, angular velocity and angular acceleration. Just discuss one very good example for it. So there is a water bottle in front of you, okay. Now I am going to rotate it like this way. When I will rotate it like this way, you can check clearly. Axis of rotation is this bottle. So axis of rotation is held in your right hand. I am rotating F like this way. In which direction the cap is moving? Is it moving upward direction? Yes, it is moving in upward direction. What it will indicate? It will indicate us direction of angular velocity. See, angular velocity is in that direction, that's why it is moving in upward direction. But when I'm going to rotate it like this way, what will happen? See. So now I'm rotating it like this way, no? So curved fingers are indicating direction of rotation. Then the thumb outstretched will indicate of motion or direction of velocity or direction of acceleration. So this is the right hand thumb rule. Again I will repeat. Imagine the axis of rotation to be held in your right hand with the fingers curled around it, or fingers curled around the axis and the thumb outstretched along the axis. In this situation, if the curled fingers are indicating direction of rotation, then the thumb outstretched indicates direction of angular displacement, angular velocity and angular acceleration. Let's proceed further. Now over here, when it is in upward direction, alpha is going to increase, and when it is downward direction, alpha will decrease. So when it is in upward direction, we will call it as acceleration, and it is known as deceleration. In downward direction, it is known as deceleration. Means it is moving towards stopping point, and when it is moving upward, it is moving towards not stopping point, increasing velocity point. Is it right? Now you may ask me question, sir, is there is relation between this linear velocity v and angular velocity omega? Yes, there is a relation between linear velocity and angular velocity, and we are interested in finding out that relation. For that purpose, check the diagram which is in front of you. Consider particle performing UCM. What is UCM means? Uniform circular motion. Consider particle performing UCM in anti-clockwise sense. In this diagram, it is moving in anti-clockwise sense. Performing anti-clockwise sense. Initially, particle is at point B. After some time, particle will reach at point C by covering angle delta theta and by covering arc delta S. Let O be the center of the circular motion. So first of all, you are going to draw this diagram. Suppose the question will appear in examination, that is state the relation between linear or prove the relation between linear velocity and angular velocity. Then first of all, you are going to draw the diagram. Minor asked, why are we calling it delta? See, delta, when we are using delta letter, when the things are very small or when we want to indicate difference, then we are going to use delta. Is it right? Getting it? So when we are going to use delta we are going to use for very small factors. Now radius vector going to travel from O to B, OB to OC. So and if it is very small, then we are going to use delta theta or delta S, or partial, not complete. Okay. So if the question will appear on any question or any proof, then for all proofs in physics there is only one method. First draw diagram. After drawing diagram, explain the diagram, then mathematical steps, and at the end there is proof. So first of all, you are going to draw this diagram. After drawing diagram, you are going to explain it. How you will explain it? See, I will explain. Consider a particle performing UCM in anti-clockwise sense as shown in the diagram. Initially, particle is at point B. After some time, it will reach at point C by covering angle delta theta and by tracing arc delta S. Let O be the center of the circular motion. Here, a description of the diagram will get over. After description of diagram, you are going to move towards its proof or mathematics. Now, according to the definition, velocity is distance traveled per unit time. Is it right? So, velocity is equal to distance upon time, delta S upon delta t. But we are knowing angle equal to arc upon radius. Over here, angle is delta theta, arc is delta S. So, delta theta is equal to delta S upon r. So, can we write delta S equal to r delta theta? Can I put this r delta theta in the formula of V? What is the formula for V? Formula for V is delta S upon delta t, no? So, at the place of delta S, I will put r delta theta. But in very limiting condition, it will become limit delta t tends to 0, r delta theta by delta t. Initial formula delta S upon delta t is not for limiting condition. But in limiting condition, limit delta t tends to 0, r delta theta upon delta t. What is r? R is the radius. Is value of radius going to change? No. Is it right? Yes. So value of r is not going to change. So can we take it outside the limit sign? Yes. So take it outside the limit sign. Then our formula will become V equal to r limit delta t tends to 0 delta theta by delta t. But what is this limit delta t tends to 0 delta theta by delta t? Are we seeing this formula by any chance? Yes. This is nothing but a formula of omega, angular velocity. Is it right? Omega is equal to limit delta t tends to 0 delta theta upon delta t. So the formula will become V equal to r omega. This is the formula for velocity. What is the formula for velocity? V equal to r omega. In vector form, vector v is equal to vector omega cross vector r. In vector form, it is vector v is equal to vector omega cross vector r. Let's proceed further. And don't forget this formula, v equal to r omega, very important formula which we are going to use throughout the process. As we discussed, relation between linear velocity and angular velocity over here. Next point, relation between linear acceleration and angular acceleration. So according to the definition of linear acceleration, time rate of change of velocity is the magnitude of acceleration. Is it right? So a is equal to delta dv upon dt or delta v upon delta t. But we are knowing, just we discussed what is formula for v equal to r omega, no? So can I substitute r omega at the place of v over here? Okay, so after substituting, acceleration is equal to del d by dt r omega. What is r? R is radius, and is it constant? Yes. So we can take constant of outside of the derivative. So after taking r outside of the derivative, it will become a r d omega by dt. What is d omega by dt? D omega by dt is angular acceleration. D omega by dt is angular acceleration alpha. So formula is a equal to r alpha. In vector form, we can represent it vector a equal to vector alpha cross vector r. So in vector form, vector v equal to vector omega cross vector r, velocity. Similarly, over here, vector a equal to vector alpha cross vector r. There are two homework problems. I will request you to note down these homework problems which we are going to solve in, which we are going to put on block in our tomorrow's session. Answers of these questions we are going to put on block in our tomorrow's session or before tomorrow's session. Mail your answers to our EdNextApp mail ID. I will read. The extremity of our hand of a clock moves 1/20th as fast as minute hand. What is the length of our hand if minute hand is 10 centimeter long? Again I will repeat. The extremity of our hand of a clock moves 1/20th as fast as the minute hand. What is the length of our hand if the length of minute hand is 10 centimeter long? This is the JEE main question. Try to solve it and mail it to our mail ID tomorrow. Find the speed at which points on the equator move as Earth rotates about its axis. Means, in other words, we want to find out speed of Earth, and for that purpose, a radius of Earth is given, that is 6400 kilometer. I will suggest you formula v equal to r omega. Omega is 2 pi by t. For one rotation, time taken by Earth is how much? We are knowing. I will not tell you the number. You are knowing the answer. How much time it will take to complete one rotate for the Earth? Is it right? So v equal to r omega. Omega is 2 pi by t. So r into 2 pi by t. Yes, यहाँ type 24 hours, right? Try to solve it. Both questions are JEE main based questions. Okay, try to solve it. Okay. So we will stop at this moment. Please give your valuable feedback in chat box. In the tomorrow session, we are start with very interesting part of the chapter.